So yesterday we started to identify those prime numbers. Now we said that number 1 is not prime or a composite, so we crossed it out. We said that number 2 is prime because the only way to get a 2 is by doing 1 times 2. But that the 2 was the only even number that is prime. That all of the other even numbers are composite. So we went through and we scratched out all of the even numbers, which would be everything that ends in a 2, everything that ends in a 4, everything that ends in a 6, everything that ends in an 8, and everything that ends in a 0. What did we say about the 3 yesterday? It's prime because the only way to get a 3 is by doing 1 times 3. What did we say about the 5 yesterday? Prime because the only way to get a 5 is by doing 1 times 5. What did we do with all those numbers underneath the 5? Why did we mark them out? They're all divisible by 5. So anything that ends in a 5 is divisible by 5, meaning that all of those numbers have more than 2 factors. They're all composite. All right, keep going along our list. 7, prime or composite? Prime. 1 times 7 is the only way to get it. 9, prime or composite? 1 times 9, 3 times 3, so 9 is composite. 11, prime or composite? Prime. 1 times 11 is the only way to get it. 13, prime. 17, 19, 21. Why is 21 composite? 7 times 3. 3 times 7, 7 times 3 means the same thing. What about 23? Prime. 27. So 1 times 27, 9 times 3, 3 times 9 is composite. 2 times, or 29. Prime. 31. Prime. 33. Why? 3 times 11. All right, so 33 is composite. 37. Prime. 1 times 37 is the only way to get it. 39. 1 times 39. 3 times 13 is 39. All right, what about 41? Prime or composite? Prime. 43. Prime. 47. 1 times 47. What else? 47 is prime. Now 49 is composite. That's 7 times 7. 51. What's 5 plus 1? So if we add the 5 plus 1, we get 6. And I know that 3 can go into 6. Right? So that means that 51 is divisible by 3. It's 3 times 17. That's not something that we have memorized, but we need to memorize that divisibility rule. So 51 is composite. What about 53? Prime. What about 57? What's 5 plus 7? Is that divisible by 3? So you can do 57 divided by 3. That's 19. 3 times 19. 59. Prime. What about 61? Prime. 63. Composite. 6 plus 3 is 9, which is divisible by 3. So 63 is composite. What about 67? Prime. 69. 6 plus 9 is 15, which is divisible by 3, so 69 is composite, yes. 71. It's prime. 73. Prime. It's prime. 77. 7 times 11, right? What about 79? It's prime. 79 is prime. 81. Composite. What times what is 81? That's a perfect square, isn't it? 83. Prime. 87. Why? 8 plus 7 is 15, which is divisible by 3, so 89. Prime. 91. Prime. 93. 9 plus 3 is 12, which is divisible by 3, so it's composite. 97. Prime. 99. Why? Thank you. So, will you please make sure that you have these numbers circled? So I'm going to read them off. You be looking at your chart, and I'm going to read off the ones that you should have circled. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 91, 97. So now that we know the prime numbers all the way up to 97, we're going to be able to do prime factorization, because what prime factorization is writing prime numbers that you can multiply together to get another number, okay? And let me show you what I mean, and then I'll teach you how to do it. If I had the number 60, and I wanted to write this in prime factorization, it would be 2 times 2 times 3 times 5. Do you all agree that those four numbers are prime? 2, 3, and 5, those are all prime, correct? If we multiplied these numbers together, what is 2 times 2? What's 4 times 3? What's 12 times 5? 60. Now we would actually write the answer as 2 to the second power times 3 times 5. That is really the way that you write this. So we need to come up with a strategy for being able to turn 60 into that answer that I have boxed in. And what we do to make that is a factor tree. A factor tree. So you've done these before. Oh, well, wonderful. Hi, Josh. So when you're making a factor tree, I want you to think of two numbers besides 1 times 60. Two numbers that you can multiply together to get 60. You could do 30 times 2. That is an option. What other options would we have? 10 times 6. 15 times 4. 12 times 5. All right, so again, there are options that you have here, but you can choose any two numbers you want to except 1 times 60, because that's not going to help you, okay? Now, of these two numbers that we chose, 30 and 2, are either one of those prime? 2. 2 is prime, correct? So please circle your 2. I want you to think of that as kind of like being a stop sign. We don't need to do anything else with that. But 30 is not prime. We can do 1 times 30, I know. But what else can we multiply together to get 30? We could do 15 times 2. We could do 3 times 10, right? That would be an option. Is 15 or 2 prime? Either one of those? 2 is prime. So again, circle your 2. That's a stop sign. Now our tree does not go any further right there. Is 15 prime? So 1 times 15 or 5 times 3. Is 5 prime? Is 3 prime? So what I end up with are all circles. It's the end of each branch. And I know that I'm finished. And then it makes it easy for me to see those 4 prime numbers. I see the 2, the 2, the 3, and the 5. You always want them in order from least to greatest. Okay? So again, you want to list them in order from least to greatest. It's kind of like not simplifying a fraction. Edwin's question was, if you don't put them in order from least to greatest, then it's not right. It's a different answer. And I said it's kind of like simplifying a fraction. 4 over 8 is 1/2. You shouldn't leave it 4 over 8. You should simplify it. Okay? So prime factorization is the same way. List those prime numbers in order from least to greatest. And then if you have any numbers that repeat, like we have 2 2's, then you want to use an exponent to put those 2 2's together. So 2 to the 2nd power times 3 times 5. And then you're finished. So we're going to do some practice in our notes before I let you practice on your assignment. Okay? Now, since you did this last year, I'm hoping that some of you remember doing it last year. All right, let's try another one. Let's do 12. So I need, besides 1 times 12, I need 2 numbers that I can multiply together to get 12. I can do 6 times 2, sure. Are either one of those 2 numbers prime, 6 or 2? The 2. So circle your 2. 6 is not prime. What can I do to get 6? 3 times 2. We already said that 2 is prime. Is 3 prime? So we don't need to do any more branches. Our branches are all stopped. So I'm going to write these circled numbers only, the circled numbers only, in order from least to greatest. Least to greatest. And then I want to write any number that repeats with an exponent. How do you write 2 times 2 using an exponent? Keely? Good. 2 with another 2 on top. That little 2 tells you how many 2's you have. Times 3. And you're finished. There are lots of 2's in factor trees, you're right. Let's do 75. 75. I need 2 numbers besides 1 and 75. 2 numbers I can multiply together. 25 and 3. Was anyone else thinking about money? I was. Whenever I see 75, I think about 75 cents. 3/4, that's right. So 25 and 3, are either one of those prime? 3, so what do I do to it? Circle it. What do I do with that 25? Break it down. Nice. What times what's 25? 5 times 5. Is 5 prime? Yes. So stop and stop. So I have 3 numbers circled. That means I have 3 prime numbers that I write least to greatest. 3 times 5 times 5. And now I'm going to write this with an exponent. It's going to be 3 times 5 to the second power. All right, I'm going to give you your assignment so you can get started. And if you need help, then I will help you, or other people at your table may be able to help you as well.